Oh yes. Okay. Good morning, good afternoon, good evening. Selamat pagi, siang, sore, sore, malam. Ohayou, konnichiwa, konbanwa. Welcome back to another me watching tutorial. Oh yeah, I forgot. I should also open the Unity. Peanut, welcome. You will be his co-pilot. Just in time, oh yeah. You just went back from Japan. Continue. Yeah. Wait. Oh yeah, continue. Oh yeah, the United. From the working. Get ready. You need one. Start your engines. This one. Is already. Pedal to the metal. Oh yeah. This one, yeah, okay. In this lesson, you will make your driving simulator come alive. Long Palm, welcome. You don't know that they have these useful courses now? I see, yeah. Back then, I knew it already, but I only did one. This one, get ready for Unity Essentials. I wonder when was it? Oh yeah. And then, yeah, that one is already destroyed. Been destroyed. How to actually delete this from the list? How to delete it from the list so that I cannot see it? Long, yeah. Along, oh yeah. Shenlong, the dragon in Dragon Ball. I guess the only dragon in the Dragon Ball. No, that was another dragon, but it has hands in the Namek planet. Start learning right from activity because it's already destroyed. Yeah, hold that. One in progress, okay. But this is still visible. How to delete it? And okay lah. Let it be.
We've positioned the vehicle at the start of the road with an obstacle directly in its path. Well, last I checked, this wasn't a parking simulator, it's a driving simulator. So we're going to give this vehicle a little gas. And by the end of this lesson, the vehicle will drive down the road, crashing through the obstacles in its way. In Unity, all of the game objects in your scene are made up of components. And it's these components that determine how your game objects will look and behave in the scene. So if you want a game object to behave differently, you just need to change its components. Let's take our vehicle for example.
Components.
Right now, it doesn't have a lot of components. It just sits there doing nothing. In fact, it doesn't even obey the laws of gravity. If you raise it up in the air, it would just float there like a vehicle-shaped cloud. But if you add a particular component that tells it to obey gravity, it'll fall. What we need, though, is a custom component that will make this vehicle drive down the road. So, we are going to create that component by programming it from scratch in a new C# script. After we write the code that will move a game object forward, we'll apply that script component to our vehicle, and our vehicle will move forward. As you'll quickly find out, programming is very powerful. Just a single line of code will make that vehicle fly down the road. So to make all that happen, I'll see you in Unity.
Fly down the road. After doing it, I loved it so much. But it spoiled your expectation from Unity. I thought they had great courses like this. I tried to take more courses from them, but too bad the other ones were bad. I see. Create and apply your first script. Pedal to the metal.
Now watch and pay attention before you do this yourself. We have our layout set up nicely here in Unity, so everything is nice and organized. We have our scene set up. So now we're actually going to create our very first C# script to be able to control this vehicle's movement. In order to do that, we're going to go to our project window and then make sure you right-click on the assets folder. And then you're going to go to the create button and we're going to create a new folder. We're going to name this folder scripts because this will actually be holding all of the scripts that we'll use to manage all of the interactions in our game. Now, it's very important, especially as you start a project, to keep all of your different folders organized so that way it's easier to find all of the different things that you need, whether it's your assets that you're using in your scene, like in our course library, or different scenes that we need to manage, or in this case, our scripts, so that way we know where all of our programming is being done. Now, what we're going to do, we're going to make sure it gets added to the scripts folder, so we right-click over our scripts folder, and we create a mono-behavior script. Now we're going to name this script player controller, capital P, player, capital C, no spaces, controller. Now, when we press enter, Unity will automatically create this script for us, and we can actually preview it on the side. So you might be wondering to yourself, why did we capitalize the P and the C, and why are there no spaces?
P and the C.
Well, this is actually something called a naming convention, and this is just a standard thing that developers do and people do when they're creating their projects as a way to make it easier for other people to jump into somebody else's project. So if somebody were to play around in your Unity project, they could understand the scripts and all of the things that they're supposed to do and what they are. So capital letters for each word in a script makes it really easy for people to know that what you have is a script right there. Another reason to name scripts up front is because it can actually create a pretty large problem in Unity. So what I'm going to do is on my scripts folder, if I right click on it and I click create script, and I don't know what to name this script for now, so I'm just going to call it test. And so here you can see that the test script is created, and you can see that it's previewed over in the inspector. Now, say later down the line, I want this to do something. I don't know, maybe for some reason I want to make the obstacle fly or something like that. And then I press enter. So we've renamed this script to be obstacle fly, but in our inspector, you can see the preview of our script. It's still called test, even though we just changed it. So this could actually potentially break things in your project and create conflicts between the name of what you have in Unity and the name of your script. And so it's just better to name everything up front, name it exactly what you want it to do, and make sure that you use the standard naming convention so that way it's easier if other people have to jump into your projects. So I'm going to just right click on obstacle fly, and I'm going to delete this from my scripts folder because we don't need it. So we have our player controller script now, and we're going to left click and drag it onto our vehicle. And now, if I click on my vehicle, you should see on the right side in the inspector that there's a player controller script that's been added to our vehicle. Now, scripts are the way that we're going to actually create all of these different interactions for any of our obstacles, our vehicles, even our camera in our environment. And so when we want something to do something, we need to use scripts to be able to tell Unity what we want that thing to do. In this case, our player controller script will make it so we can actually move our vehicle and control it. In addition, when we dragged our player controller script onto our vehicle, you can see that it was added here in the inspector, and so it was added to our list of different components. And so our components are basically the different properties that we can see attached to all of the objects in our scene. So, for example, our vehicle has our transform, so it can control the position in the world, how it's rotated and oriented, the scale. We added our player controller script, so we know that we're going to create a behavior for this vehicle. And then there's other things too, like mesh renderers and mesh colliders, both of which we'll get into later. A mesh renderer just helps to actually enable Unity to show you the vehicle with all of these textures applied onto it. And the collider will actually be something we use later so that we can have our vehicle run into our obstacle. Now, for example, if we went onto our obstacle and we accidentally added our player controller, which we can also do by left-clicking and dragging onto our inspector. If the selected object is highlighted, we can add it that way, but I don't want the player controller on this obstacle, so I can click this icon next to it, and we can actually remove that component.
Remove.
Or if I wanted to add a component another way, I could also click the Add Component button, and you can actually see all the different components that you could use if you ever wanted to, or you can just type in the name. So we have that player controller, added it there, but we don't want it on our obstacle at all. So what you're gonna do is you're going to right-click on your assets folder, create a new folder, name that folder scripts, so that way we can see where all of our scripts in our game are being managed and organized. On the scripts folder, you're going to right-click directly onto it and create a script, which you will name player controller, capital P, no space, capital C, and then you're going to add the player controller script either by left-clicking and dragging it and dropping it onto our vehicle, or if you select the vehicle by clicking on it, you'll see it pop open in the inspector. You can left-click and drag the player controller into the list of components, or if you have your vehicle selected, you can click on the Add Component button. You can type in the search bar and type in player, and that'll pop open your player controller script that you can see here, and you can add it that way. Now it's your turn.
Okay. It looks pretty easy. Script. Yung Laura NCT mo kan malam-malam. Welcome to the stream sa Mandelta. Player controller. Ah. This one with icon. That looks like Iowa edition. Looks like sharp. It's actually the script. I see. We'll have a problem here. Oh, what is it? Please tell me. Just a little bit, I guess. What you guess to be a problem? Tre? Best friend the mas collider. Player script. Yeah, okay. I'm going to open this. The next step must be inserting some words into it, right? What is it? Why does it not open the script? What is it? About the new way Unity organizes the context media. So what was showing in the video doesn't match perfectly with the Unity at the monopiefera script. Was located somewhere else. I see. Solution Explorer. Wait, open C project or maybe open this is different choice I guess. Open. Oh yeah. Can already see it, yes. This is a dragging. What it is? I see. Okay. There are two different buttons, yes. Actually, but we peanut and lotan. Are you sure? If you know it's under. I don't know. It seems the name looks like Vietnam. I don't know. But did you guess that? Long Pam's channel contains something like game something 3D. I mean 3 years ago. It looks 3 years ago. I just saw. Does his name look Vietnamese too? No. But he said it. Also in the video, I made Long Pam's video content something that looks Vietnamese. The title text. So maybe your true came from the same place, I guess. I don't know. Just a guess. So yeah. And welcome. Mayam. Hari ini belajar Unity lagi. Add a comment.
We've created a scripts folder and we've created our first C# script.
A comment.
And we've applied it to our vehicle as a component.
Never mind. Update. Move the vehicle forward. Yeah, right?
And now we're actually going to...
I can skim this, right?
Expanding it. And then if you double click on the player controller script, now you can see that my script has opened up in my IDE, which stands for an Integrated Development Environment. And basically, an IDE enables us to actually interact with our code and write lines of code and text inside of it. So you can actually see there's words that you would be very familiar with, like words like using and public and class. And so very similar to how you would write a note or write an essay in a text document, our IDEs enable us to actually write for our programs. So I'm just going to clean mine up a little bit. There's a whole bunch of information here that's not entirely necessary, so I'm actually going to go on my IDE, close this little Solution Explorer. I don't really need that. I don't need the Team Explorer either. I don't need the properties. Cool, so now I have a full screen. I'm going to make this a little bit larger, just a little hard to see. So on the bottom left, I have this little zoom option. 200, pretty good. Now, my IDE is set to Visual Studio. That's actually the default that you would get downloaded on Unity. If not, you can always go to the website to go download Visual Studio from Microsoft. You might also notice that some of the colors are very different. Maybe you have a white background. That's just a setting of mine. I just turned my settings to be a dark background. I use different colors for words because it helps make it easier for me to see. So you can change those settings on your own. Or if you're using a different IDE, then you should be able to customize it in your own ways. But if you download Unity for the first time, you can download Studio. Now, if we take a look at our class, I mentioned it before, but you can see all these words that are very familiar to you. Words like using, words like public and class. And a really helpful thing about an IDE is that in my case, it actually highlights certain words that are very important for a person and a computer to understand. So the different words that are actually highlighted in blue are standard keywords that your computer is made to understand.
with our script itself, our player controller, you can see the name that we made before, and in fact, there's this weird colon icon. And so that icon actually means that this player controller inherits from another class called monoBehavior. And monoBehavior is actually a class that's applied to all the different objects that we create. So actually, if we made a script for our obstacle, it would also use things from monoBehavior. And that's very helpful because in monoBehavior, a lot of different things that we would need to write ourselves are already made in Unity. So it's really helpful and really easy to get started. For example, we have these two methods here, and you can tell they're methods because they have the word void, and then they have these parentheses, and then they have these curly brackets. So this usually tells you that this is a method statement, and here's actually where we can go write in some code if we wanted to. So start is a method that, as you can see, actually has a comment up here that is called before the first frame update. So when you press play on your game, it would call start method. Versus the update method, another method from monoBehavior. And update is called once per frame. So this is actually constantly checking in your game for different calculations it should make, or different things that it should be checking against if you have a box that collides with something else or something like that. And the difference here you can see, so these two forward slash marks actually create a comment, and your computer will not read what is on this line of code. So comments are for the purpose of a person to understand what they're reading inside of a method, versus the methods are actually the pieces of information that your computer needs to run certain tasks. So now, in our update method, we're going to write our very own comment. So make sure that you have your text selection inside of the update method. And then if you write / two forward slash marks, we can say, we'll move the vehicle forward. And so now this is where we're going to write our line of code to move the vehicle forward. But for now, we're just going to make a note for ourselves that this is where we're going to do it. So what you're going to do is you're going to double click on your player controller script
Yeah, huwag.
code to move the vehicle forward.
Okay, Amar. Okay. Comment is easy. I don't need. Okay? But thank you for the tutorial. Let's go.
We've opened up our player controller script, and so now we
I
can
am
see
right.
all of this code that's inside of this script.
Coworker
And
of
so we'll
yours.
actually write our own line of
Like
code
close friends.
so that we can make the vehicle
I
move
see.
forward from our little note we
Ah.
made for ourselves before. Make sure you pay attention
So my
before
guess
you do
was
this.
right.
So what we're gonna do is we're going to write our very first line of code here in our update method.
Okay.
So if I select this text block right after the word forward, if I press enter, so this creates a new line. So in programming, a blank space doesn't matter. Our computer just knows that there's nothing there. And what we're gonna do is we're gonna program using a programming language called C#. So everything that's done in Unity uses C#. If you're going to make a mobile application or if you're going to make a website, there are other languages that you can use to create those different kinds of applications. But for our game, we use C#. And C# is just one way that we're able to communicate directly with our computer using certain words that a computer is able to understand to do something that we want it to do. So in this case, we're going to write a line of code to move our vehicle. Now, what I'm going to do is I want to help visualize moving this vehicle down the road. So if I actually select the vehicle in my project hierarchy, so now you can see it's selected. If I left click on this blue arrow, I want to move the vehicle down the road. You can see down in the game screen. That's exactly what I'm trying to do. In fact, if you look in the inspector
Increase
on
the
the right
Z.
side, as I'm moving this blue arrow in our transform component,
Chat plus.
you can see that the Z is actually
Transform,
updated.
translate.
And so that gives us a really good hint of
0,
what
0,
we're trying
1.
to accomplish.
That
So
means
if you
move
remember,
0.
our transform
move to
component
1Z.
was the thing that was updating as we moved
I
that
see, I
vehicle
see.
in the scene. In fact, we can actually use the transform component directly. So if I just type in transform, and in this case, lowercase versus capital case T is extremely important. They're two very different things. The transform is actually an entire class, very similar to our player controller class. It has even more
Transform.
methods inside of it. A lowercase t means we're getting the transform component of our current object. In this case, it's going to be our vehicle. So now that we're getting our vehicles transformed, what we actually want to do is we want to move that vehicle in that Z direction. So we can use a method using a dot. So a dot will help us get methods out of our different classes and objects. So dot translate. So you can see here this is a capital T because this is a method just like our update method. And so what is happening here is we're telling our computer we want it to do a specific instruction using this translate method. We want to translate the position, we want to change the position of our vehicle using its transform property. Now to tell the computer that we're trying to make it do a task, we need to use these parentheses. And a really handy thing that my IDE does it is actually
They make
suggests
this,
different things that I can do and can autocomplete certain statements
picture.
that I make if I'm trying to write code or
Instead
if I'm
of
trying to in this
text.
case, it's suggesting different things I can do with our transform.translate. So this here you can see
So
we've
that
got a translation,
people
there's a
doesn't-
translation. So this is a parameter. This is a piece of
doesn't
information
just
that I tell the computer
copy-paste.
to use to be able to do the thing that I want it to do. Now I don't necessarily know what
factor 3 is right now. So let's see if there's other options. You can see there's 6 total options, and this one seems to be
That's a
really
great
useful.
thinking.
So this one actually says that it will move the transform.
Great
It'll change
thought.
that position by the X, by the Y, and by the Z. If you remember, I was trying to move my vehicle on the Z. So what I can do is,
They
I
make
don't want my
this
vehicle to move
picture
to
not
the X
text.
direction. I don't want it to move left or right, so I'll just type in 0. I don't want my vehicle to move up or down. It's not a plane or a spaceship, so that's also 0. But I do want to move it in the Z direction, so I'm going to make that 1. Now that we've added our parameters to our method and we have that closed parentheses, we actually now need to add a semicolon. And so the semicolon actually tells your script that the method is now complete. So you can think of how we use periods to end our sentences and close our statements. When you're programming in C#, you use a semicolon at the end of your method to tell the script that this is the end of this line. So now what this will do is update is called 50 to 60 times every second. So in a second, our vehicle will move 60 units, 60 meters in a certain direction. So now if I test this in Unity, when I press play, I should see nothing. Okay, that's not what we want to happen. Let's see. Get out of play mode. What did I do wrong? So let me just player controller. Oh, I forgot to save. So you can see in our project window, I selected our player controller script, and it looks exactly like how we left it when we first opened it. There's no information inside of it. But as you can see in our script here, we've added 2 lines in here. We've added a comment, and we've added this method that we created. So the problem is we didn't save. Simple as that. So if you just press Control or Command S, now our script is saved. You can see now in Unity, in our inspector for the preview of our script, we can see those lines of code now. So now when I press play, I should see the vehicle move. There it goes, speeding all the way off the runway. It's flying off into space. Maybe it's a spaceship. Cool. So we've written our first line of code to move our vehicle. So what you're going to do is in your player controller script, underneath your update
Yahoo,
method, inside of your
Nagasora,
update method,
welcome.
underneath the comment, you're going to write transform
Welcome to
dot
the stream.
translate, and then you're going to use an open parentheses, type a 0, comma 0, comma 1, close parentheses, and then semicolon. Now it's your turn.
Did this train lazy student and those who don't pay enough attention and yawn a lot? Are you sure? Transform, transgender nih. Translate. Transition. Trust Translate. Trans on time. Trans on time. Not late. My trans is not late. It's on time. It's just like here, right? What if we don't finish it with the semicolon? Belajar iya. Compiler errors. Oh yeah. Never mind. That was compiler error. Because in game Maker Studio, because in Game Maker Studio, they don't really need the semicolon for obvious line. So you press enter, it's equal to semicolon. Different language, yes. I was just trying. Since I haven't done this one right. How about what can I make? Random. Class Unity Engine dot random. Is there something? Random. Mathematics. They include their using today someone can wait the video and ask Dr. a fine question if the compiler knows that we miss a semicolon. Why doesn't it add it for us? I was like, yeah, why? So I proceeded to modify the compiler Just that attach. Semicolon frame nih. Crazy guy. Basic. Wait. How do I do random? Random. +1 overload. +1 overload? What is that? Randomizer, random chat. Random number generator. Smooth random. Range bin. Describes an integer range. Range. Range attribute. Can Google if you don't know how to use random. Oh yeah. I guess later. Okay lah. I was just trying to mess. Okay, complete. It's not real random. A random with a pattern. So that you can guess the pattern somehow. First random is good. Vector 3 forward. Vector 3 dot forward.
Our vehicle now moves virtually at the speed of light, just flies straight down our screen. So that's good. We've got the movement in. Now I just want to highlight some things with coding to make our lives a little bit easier. So, with our player controller script open in our IDE, my IDE does some really useful things to make my life a lot easier. So one of the big things first is if I start typing a word, say transform, it automatically tries to suggest the word that I'm trying to type, in this case transform, and I can press enter, and it'll complete that word for me. Now, if I type dot or period or full stop, you'll see that my IDE suggests all of these different words. And a lot of these words, especially if they have this little purple icon next to it, these are all actually other methods that I can use, just like our translate method. Now you might hear people say methods or functions in Unity and in C#. They're essentially the same thing, but a lot of people just tend to call things methods when you're using these kinds of statements here that have parentheses. Now, you can think of all of these different words very similar to how you would think of a dictionary. And so a dictionary helps you understand a word that you're looking for. In this case, in programming, this is called documentation. And so our documentation, or our dictionary, tells us all of the different words, all of the different actions that we can perform with our transform component here. So I'll use translate again. And now, if we push that dictionary analogy even further, so we have the word translate. And if I use an open parentheses, you'll see that now my IDE suggests different parameters, different pieces of information that I can tell it to use to do something. You can think of this very similar to a thesaurus and synonyms, where many different words have a similar meaning. In this case, we have many different kinds of methods, and these methods all have different ways that you can essentially do the same thing. So in this case, it's asking for a vector 3 translation. Now, in order to get a vector 3, I can actually just type vector 3.
Vector 3 is
now,
x, y,
you can
z.
actually see we actually have a suggestion as to what a vector 3 is, which is super helpful. So my IDE tells me that a vector 3 is a representation of 3D vectors and points.
3D vectors
What
and
is that?
points.
Well, in fact, that 0, 0, 1 is just 3 dimensions of points, 3 different points that we use, a 0, and a 1. In fact, that 0, and that 1 all correlate to the position on our transform component. So we have the 0 on the x, the 0 on the y, and then our 1 is actually the z updating over time. We even have these vectors, these 3D points, in our obstacle with our position. You can see the 0, 0, and the 25. That's a vector 3. That's 3 different points that we're storing. So with that information, it's very helpful because we can actually just shorthand this bit of code that we wrote with 0, 0, 1. In fact, if we use dot and then forward, you can see that forward is actually just shorthand for writing 0, 0, 1. So that actually, can save us a lot of time, and especially is very helpful to making our code easier to understand. Because if I told a person to move something 0, 0, 1, they'd be like, I don't know what you're talking about. But if I tell them to move forward, they know the direction of forward. So this is how different keywords in programming can help make our lives easier, to make it easier to understand what is in front of us, but then also translate that into something that the computer can understand. In this case, the 0, 0, 1. So if we remove now our previous line of code, now we'll just make sure that we save. Always make sure you save before you go back into Unity.
I will not use that.
In our player controller, you can see that our translate method has changed from 0, 0, 1 to this vector 3 forward. And when I press play, our vehicle is still flying all the way off the screen.
Thing.
So, looks like our
because
code
it's not
did
detailed.
exactly what we wanted to do before, which is great.
It can only do 0, 0, 1.
So what you're going to do in your player controller
or 1, 0, 0 on the,
you're going to change your
or
line
0,
of
1,
code
0, right?
from 0, 0, 1 to vector 3 dot forward. Now it's your turn.
Yeah. Rama Sanchez, welcome. Welcome to the stream. Vector. Vector 2? Wait, vector 2? There is also vector 2. Smallest components of 2 vectors. 0, 0, 0. Up 0. Vector 2 from vector 2 to gets the unsigned angle in the crease between from and to. Dot. It never had code. The number 1 or none anyway. If you have the chance, then it's the same thing as vector 3 forward or vector 3 forward times 9. So that vector 3 forward thing can also be multiplied or something. I see. Back down. Forward. FWD. Pattern multiplication is essential in math. Oh yeah. Well, I thought the program will not do that. my assumption. My game maker studio assumption. Because it doesn't do that there. Once you call an array or something, you cannot multiply everything inside it with just multiply 9 or something. Negative infinity. Leftovers. Positive infinity. As I said, FWD has the word deprecated. Recommendation for developers to avoid using deprecated or obsolete things. Deprecated. Ah, yes. So what's then backward? No, there is only back. They discriminate. They discriminate the backward. Because back is shorter. Again lah. It should have been front. Front and back. Way forward and not backward. Front and back. Up 0. Oh yeah. I want it up. You want frontward? No, front. What is the antonym of back? Front. What is the antonym of forward? Backward. It's not back, but backward. Baik. Mariko welcome. Zaman Sanchez welcome. Oh yeah, just in case. Maybe I forgot. My mind was focusing. Oh! The car just flies. Vector up times 0.05 maybe. Let's try. How do you... What's wrong with this? .05 F is within it. Estes. Introduce constant. Float. Private. Float fee. Variable. I see. It makes me make a variable. Wow. It's quite slower. Float, yes. Float ice cream. and the truck is floating. Well, that is slow because 0.0005. And why did I choose 5? Yeah, my favorite number. Somehow. Also Peanut's favorite number. There is a door. Having that favorite, yeah. Isn't your favorite number is mine? No, it's our. This is not a bug, it's a feature. Yes. Forward. Okay lang. Mark as complete. When niya bisa kerja bermandi, yes, niya tinggal kerja sekarang lah. Kalau na welcome. And the situation iya, game the stream ni. Do you like cheeseburger? I like. Oh yeah, I just ate cheeseburger. I mean, on the lunch. For lunch. How to him did you have access to cheeseburger? Because cheese and burger.
We've fixed our vehicle, so now it flies down the screen once again, extremely fast. At least our code is a bit more readable, but now we need to slow that vehicle down so it doesn't just fly off into the distance. So in our player controller script, we're actually going to use a little bit of math in this method to be able to slow our vehicle down.
No.
So first what we're going to do is we're going to want to change the way that we move our vehicle. So currently the way this works is our update method is called every single frame. But depending on how powerful your computer is, you might get 20 frames in 1 second, you might get 60 frames in 1 second, and so really your player could move at varying speeds depending on what kind of device they're using. So we actually want to change that from updating every frame to updating over time every second.
You have
so the way that we do that first is by multiplying, and for a computer, you should use the star symbol. So if you press shift on your 8 key, it'll create that star symbol. Because actually, if you press X and use the X key, it considers that an actual letter that it needs to know to use for a word.
Just ate the cheeseburger
so we use the star symbol to tell us that we're multiplying something. And then what we'll actually do is we have a class already made to keep track of time, so we don't have to write a class ourselves. So that is called time with a capital T. You can even see it highlights it in green, that way we know
Ocarina of Time remake
class. So now we're using time to keep track of our time, and we actually use delta time to get the change in time between all of our different frames. So now, using this bit of code, we can actually know when 1 second has actually elapsed versus 20 frames happening, 60 frames happening, who knows, we can't control that. We can control how much time is actually passing. So if we go test this, we press play, and our vehicle is still flying down the road, and that's not what I wanted to happen. I forgot to save again. Okay. So back in the player controller, just make sure you save, Control or Command S. That way it always updates the script in Unity. So now, when I press play, we should see our vehicle moving. Albeit very slowly, but because of that little bit of code we added, we're actually now moving 1 meter a second. You can see,
1 meter a second.
It'll probably be just about 1 unit every single second. So cool. Now we have our vehicle moving by time. Granted, it's moving very slow, but we can fix that pretty easily. So what we're going to do in our player controller, we're just going to multiply by a random number using that star symbol. So we'll multiply by, say, 20. So it should move about 20 meters every second now. So now if I test and I press play, and I forgot to save again. Always remember to save. Now when we press play, there you go. Now it's moving nowhere near as fast as before, but definitely not as slow either, which is great. As a fun little tidbit, the way that this formula actually works, this little equation that we have, so in fact, vector3.forward is storing a 0, a 0, and a 1. And so when you're actually multiplying it by the time and by 20, you're actually multiplying each of the different values. So first you multiply your 0 by time and by 20, which will always be 0. Then you multiply your y, which is 0, by time and 20, which is still 0. And then you multiply the z by time and by 20, which gets you 20 meters a second. So just a fun way to kind of see how the math works, and would definitely save a lot more time than just typing 0 times time dot delta time times 20, comma 0 times time dot delta time times 20 times 1 times time dot delta time times 20.
So if the
a really helpful way that, especially this shorthand, makes our lives even easier than before.
frame rate is 60.
So what you're going to do is, in your update method, you're going to change your transform.translate to just include a star symbol for multiply, and you're going to multiply your vector3.forward by time.delta time, and then you're going to multiply all of that by 20. So now it should move just about 20 meters a second, so that when you test your game, you press play. If you select the vehicle while it's moving, you can see the z value changing, and if you use the stopwatch, I'm sure you can see that it probably moves just about 20 times every second. So now it's your turn.
I'll just have it complete for now. Time. Delta time. The interval in seconds from the last frame to the current one. Last frame to the current one. So if it is 1 frame per second, 60 frame per second, it will be 1 per 60, I guess. So time 20 as the tutorial means like 20 per 60. Okay. If the frame rate is 60. Calvin, Hayaw, welcome. Welcome to the stream. So if the frame rate is 120, this will be 20 per 120. Something like that, right? Okay. No need to test anyway. It's already obvious.
Our vehicle now speeds along at a normal rate instead of incredibly
Normal
fast
rate.
or incredibly slow. And now we want it so that we, instead of just driving straight through this box, actually can collide with it. In order to simulate physics in our world, we actually need to add something to both our obstacle and our vehicle. And we'll do that using our components. So our
Like
component
what?
system can add a lot of different properties that people regularly use. In this case, a property that people will commonly use for physics is a rigid body, which
Rigid
is
body
a
2D.
physics concept, and in this case allows us to
That is
interact
2D.
with this truck here that we have as if it had real simulated physics on it. So now it's a solid object. You can see that on the rigid body component in our inspector. It has a mass, so we can actually make this heavier We can use gravity or we cannot use gravity. So there's all of these different options. In fact, I think our inspector is getting a little bit too crowded, so you can actually click on the little arrows next to all of the component names, and it will compress down each of the different options. So that's certainly very handy if you have a lot of different components. So now we can see our rigid body component, which is great. And then on our obstacle, we can also go and with our obstacle selected in the inspector, we click add component. If we type in rigid body again, we can add another rigid body. So now our obstacle and our vehicle both have rigid bodies, which means they're both using physics, they both have mass, they both use gravity. So that's really helpful. And then one other important component to note in our list of components in our obstacle and our vehicle is actually these mesh colliders that we have on both of our objects. And our colliders are basically our ways of telling our simulated world that these objects can be collided with. So it knows that because there's a collider on this, when it runs into something like the ground or when it runs into something like our vehicle, it should do something like make it stop because we have a rigid body on it. So if we actually press play, we can see our vehicle collides with our crate, it goes flying off. If we were to turn any one of these things off, so for example on our obstacle, if we turn off our mesh collider,
O yan.
our box actually just flies straight through the ground, and that's because our mesh collider is telling our game world that the box no longer collides with our road, so therefore it can just fly straight through because it's not supposed to collide. So really fun things that you can do, and just to kind of make
Copy
our
pipe,
little
well done.
driving game simulation a bit more realistic,
Vtuber
we're
solved
gonna
deaf
increase
Indus.
the masses
Auto-follow, makasih.
to objects just to make it a bit more fun, make it interesting. So we'll make our obstacle, our little crate, maybe about 20
Aku dulu
kilograms or
pakai ni
so.
Game Maker Studio.
And then the mass of our vehicle,
Tapi ni
I don't
baru
know, maybe
kayu
something like
nanti.
1,000. So now this has even
Ajo
more
nggak
weight
tahu
behind it, so when
apa-apa.
it hits that box, you see a slightly different effect happen. Yep, see? So took much longer for that crate to fly over the vehicle because it was much heavier. So fun little things you can do to create better simulated worlds in your games using things like colliders to tell your objects to know when they've collided with something like our vehicle and our box, or even our box and our road.
Harigin
Using
body ya.
rigid bodies to be able to create physics
Kan
on our
berkredit tuh,
objects, so
drifting.
that way our obstacle actually has
Oh,
weight,
yeah.
our vehicle has weight, and we're using gravity, so it's actually being pushed down
I
into
will
the
do
ground
drift
at all times.
after
So
this.
what you're gonna do is on your vehicle, you're going to select it in your hierarchy, and you're going
I will
to
make
go into the inspector on the
a
right
track
side,
Beyblade.
click add component, and you're going to add a rigid body. And then the same thing you'll do with your obstacle, select it in the hierarchy, go to the inspector, click add component, and then make sure you either search for or select the rigid body component out of the list. So you can do that either by going to add component, going to physics, and then you can see all of the different options like the rigid body, or you can just type in rigid body, and there it is. Super easy. Now it's your turn.
Yes. There must be something in the transfer for the angle. Rotate. Local rotation. Rotation of the parent. Rotate. Local rotate. And rotate. You going through hell now? Already forgot how to go to, but remember the first screen. Oh wait, how to use the rotate? Extract method. Rotate around local. Quick switch compiler. Never mind. Transform dot rotate. Compiler error. Vector 3-point axis angle. So where is this again? Unity and Visual Studio C#. Epigenetic rotation related is counterintuitive for beginners. I see. In the Chemical Studio, it was just a variable called angle, and you just change the angle variable and it will rotate. I don't know. X angle, Y angle, Z angle. Okay. X angle, Z angle. Which angle is the side rotation? Is Y. Z is side rotation. Oh yeah. The X is front rotation. Nah, I guess it's not counterintuitive. It's not so counterintuitive for me. Forward legs. We suddenly forward legs. Hey. Oh, with time then. Yeah. The angle. $180. Oh yeah. Nah. The front, the forward is technically forward. It's really forward. That's what the forward. The forward was needed. I see. If I don't use the forward, it will be by break. I mean like something like zero. Or is it the same? I don't know. Let's try. It's just the same. It's the same. I see. So what's the actual use of XYZ? If it doesn't move exactly with the position of the map, how can I find it in the map? I mean the position, the actual position compared to the map. If I move it this, rotate. Okay lah. What happen if you rotate to your right and move forward? Yes. You move to your right. Yes. Petro, welcome. What I mean is that I want to just increase this set. I just want to increase this set. Oh yeah. What if I is there a set variable or something? I don't know. Generate field set, the property set. I don't know. Transform. Position. I want to make it like a Beyblade, not a rotating track. I don't know. I just want to increase the Z. Not too forward. Drill track. Well, drill track maybe can also work. That will be cross gear, not Beyblade anymore. Oh yeah, it's the same. Quaternion happen when you have to actually deal with the object's rotation. Done. Let's do this. Okay, that's good. Doesn't drill. Okay lah. I mean, not really drilling. I forgot the rigid body. We forgot the tutorial. Rigid body. Maris dari rigid body. Basics. Rigid body. Oh yeah. Basics 2D. Rigid body 2D. All like they already categorized it differently from the tutorial. I saw this rigid body and rigid body 2D in the same place in the tutorial. And see, vehicle, obstacle, V6 rigid body, mess one. 1000. I see. The track just do that. Okay. That's actually easy to make. Okay. About what they would be in kilograms. The mess, yeah? Ane. Cute law, thank you. Duplicate and position the obstacles.
We've got some physics in our scene now, and we've got collisions happening. So as our vehicle's driving the road, it runs into this box goes flying. And now we're gonna make this road just a little bit more treacherous, make our game a bit more difficult for our player by adding some more boxes. Make sure you pay attention before you do this yourself. Now what we're going to do is we're actually going to select the obstacle.
What I want to
I'm just going
achieve,
to make this a little bit easier for myself. So
then
I'm
either
going to
settings or
left-click
objects
and
position,
drag the obstacle in our hierarchy and drag it all the way to
rotation.
the bottom of this list. So you see this little blue
translate and
line
rotate.
underneath all of the other
not setting.
list of objects.
I
And if we
see.
let go, now you can see our obstacles there. And now what I want to do is I need more boxes in this scene. So I'm going to select the obstacle in the hierarchy by clicking on it. And I'm actually just going to press the Control key and the D key at the same time.
Control
So I
D.
Control D on our obstacle. It immediately duplicates our obstacle. And now we have another. And you can see if I hover my mouse over the scene and I press F to focus, it's directly on top of the other box. So that's
Control
not
D and the V.
but we'll just move this one a little bit farther back. We'll try and get it to around 50 or so. I'm just going to estimate.
There is
around there is good. 50.1,
there
almost
is a
had it.
spam in the
Now we have a
Discord.
second obstacle.
Oh,
We want to add more, so if I just keep duplicating and dragging, that'll take a long time. So I can actually do something to make this a bit faster. So if I select my first obstacle and I control click on my second obstacle, now if I control D, it creates 2 more obstacles. And in fact, I can move these back even further, just about, let's call it like there. That's good. We'll shift my perspective, so I'll actually click the little green Y in our scene view. Now we have a top-down view. And now I'm going to zoom out, so we're going to Alt and we're going to right-click and drag it to the side all the way to the left, so we zoom out even more. And now we can see, maybe a hand tool might be useful for this. So I press Q, select my hand tool, there you go, so you can see more of the road now. Actually, it might help if I just turn. There you go. And then just zoom in a little bit. Perfect. Cool. Now we can see our road even better. Really good opportunity to test out your movement skills. See if you can navigate your scene. So now we have our 2 boxes. Now we're going to make another set. So now I'll select my first obstacle. And in fact, if I just hover over the last obstacle, I pressed shift and left click at the same time. Now all 4 are highlighted. Now if I control D to duplicate, I have 4 more obstacles. Now if I select my move tool, I can move all 4 obstacles down the line. Somewhere like there. Cool. You can see this last obstacle, obstacle 7, is a little bit off the road, so we'll just delete that. So I'm just actually going to press the delete key on my keyboard, and it deletes it from the scene. So now we'll save really quick, and when I press play, you can see the vehicle drives, hits one of the boxes, 2, 3, 4, all the way down. You can see them tumbling down in the game view. So, up there the vehicle goes straight down. Oh no, can we catch it? No, it's gone forever. Well, we know the physics works now, so that's great. And we hit all the obstacles, and we've made even more, so we've made things just a bit more difficult. So what you're going to do is you're going to take your first obstacle, you're going to use Control D to duplicate it, move it down the road, just using the Z axis, this blue arrow on your move tool. And then you can actually select your first obstacle and control click on your second obstacle. And then when you control D, it'll actually duplicate 2 more obstacles. So then you can move those down the line. And then you can actually just select your first obstacle and then shift click on the latest obstacle you made to select all 4 obstacles, and you can drag those all the way down the line. And then you can test your game out. Now it's your turn.
Oh yeah. Wait. Sorry, I was looking at the Discord settings for everyone's permissions because it kinda sounded someone can mention roles, but it's already off the permission. Here the permission to mention everyone here and all roles for everyone is already off, so that spams cannot suddenly mention everyone or any roles. But just note, someone just did that. Mention partners still. Yeah. It's already off though. The permission is already off. Like the channel that if you chat in it, you get auto them out. How do you do that? Yeah, okay na. Okay, so what is? I was it again. To click it, yeah? I already made a lot of the obstacles with different shapes. But I guess the body doesn't go together, yeah. Control D. Duplicate. I can also duplicate by doing right click. Recommendation is that if you love Premiere, you don't have to work on it. But many hours a day. So have an idea and work on it later by titling free day to keep your skills sharp. Well, if I have time, I will do it many hours a day. Doesn't matter. So I can drag this. Oh yeah? Okay. Oh yeah. Oh, I think of the duplicate with Control C and V to Control A copy paste. Yeah. Oh, there is space spatial. Brace as child. Keep local world transfer. I'm going to keep this and move it faster. Yes, that. Okay lah. So that's what happens. Control click and duplicate. Yeah, okay. Adrian, welcome. Welcome. Ku masih belajar. Lesson recap. Start versus unpaid. Time delta time. Politer get body. Yeah. Step complete. Do you read tutorial? Okay, clear. Belajar sekalian codingnya? Enggak ada. Lesson 1.3 High speed cheese. Nah kan belajarnya cuma belajar. Nih jadinya gini nih. Lihat tuh. Oke lah. Sesama welcome. High speed cheese. Easier way to change the vehicle speed and allow it to be accessed from the inspector. Something called variable. Public float. Speed.
Our vehicle now can drive all the way down the road. We have all these obstacles that they can collide with. it has a whole bunch of physics applied to it, but our vehicle still moves a little bit fast, so we want to be able to change it, and we also want to be able to see it. To do that, we're going to use something called a variable. So, in our player controller script, right underneath this first curly brace, underneath player controller, we're going to create a new line by pressing enter, and then on that new line, we are going to create our very first variable. So, we're actually going to use this variable to be able to change this number here. So usually in code, it's pretty bad, especially when you have what's called a hard-coded number, because that means that if you ever need to change it, say we reuse speed for some reason ever again, we'd have to keep changing the number 20, versus we could just change the number in our variable. So what we're going to do is we are going to use the word float. Now float is a keyword that helps the computer know that we're creating a number with decimals in it. And then we're actually going to say what the name of this variable is, so we can call it speed.
Oh, it's not.
And we're going to use
It's
the equal
not
sign here.
public.
Now it's very important, the equal sign to your code is very different than an equal sign when you're doing math in the real world. So this actually will assign our speed variable a value. So our speed will be set to whatever number we put next, and it will store that number whenever we need it. So because we are using decimals, we'll type a 5.0, so this is a decimal, and then we add a semicolon at the end, so that way we know we're at the end of this line. We are done with our statement. Now you can see that our IDE is pretty mad at us right now, there's this red underline. And it says that it doesn't understand what this 5.0 means. So actually what we need to do is we need to tell our program that this is a float, and so we add the F at the end. So now, as our computer tries to understand this line of code, now our computer knows that 5.0 is supposed to be a float specifically, so we add that F at the end. So now we have our speed variable, it's always carrying the number 5. If we ever need to, we can change it to be 10 or 20, whatever we want it to be. And so where we have our 20, in our update method, where we're transform.translating our object, we'll take out our 20 and just put speed. So now, our code knows that we are multiplying by the value 5, even though we're using the word speed, so that's very helpful. So now, if we test our game, our vehicle should be moving a little slower, not bad, so it's moving about 5 meters a second, and now just pushing those boxes along. Now, we want to actually be able to see the speed variable in Unity. So right now, our speed variable is a variable that belongs to this entire class. It's what we call a member variable. And right now, it can only be seen inside of methods inside of this class, and it can't be used outside of this class. Now, we can actually use the word private to denote the level of access that somebody has with our speed variable. The private keyword is what's called an access modifier. In fact, the public keyword is also an access modifier. So private can only be accessed within this class. In fact, this start and update method are both inherently private. You don't actually need to put the word private. Versus the word public means that you can access, you can see, you can use this class in other places. So in fact, we want to be able to see and interact with our speed variable. So we will actually make this a public variable. So now that we've used the public keyword to modify its access, we should be able to see it in Unity. Now, a cool thing that happens when we go into Unity, if we click on our vehicle in the hierarchy, in the inspector, underneath the player controller script, you can actually see our speed variable now because it's public. And we can actually change the values however we want just by typing in any number. So I'll set this to 15, and I'll press play. And you should see the car zip down the road. And a cool thing I can do, if I left click and drag on the speed variable, on the word itself, if I drag it to the left, it actually brings it negative. So you can see it racing down the runway. And if I bring it up, it goes up. And so this is a cool way to see exactly how fast you really want this vehicle to go. And then 5's kind
You
of good
can
speed.
look at it in the
I'll make it to, like,
Unity
11 or so, 12, cool. Now we stop playing.
after
the speed
the
variable is
script.
set to 15. Well, if you remember, when we enter play mode, if we edit values, it'll reset those values when we exit to the way that it started when we were in our scene. So it actually set back to 15, so we'll just bring this to like 10 for now, and then we'll save. A fun little tip for when you're programming, something that people commonly say whenever they create their variable, but then also assign it a value at the same time. This is called initializing a variable. And so we initialize the speed variable to be at 5.0 for its speed. So what you're going to do is you're going to create your very first variable so we can store the speed that we want our vehicle to move. Make sure that you use the keyword public, so that way we can see this variable outside of this class and use it. Use the keyword float, that way we know that our speed variable is a number that uses decimals. We can choose what we want to name our variable, so we'll name it speed, and then we use the equal sign to assign or to set our speed to be 5, and then make sure if you use the .0, just to add an F at the end, so that way our program knows that this is a decimal number. And then in your update method, change the 20 to speed and test your game. And then while your game's playing, if you select the vehicle and then you go into play mode, you can actually left click on the speed onto the player controller and drag it, and you can change the numbers by scrolling side to side. Now it's your turn.
Yeah. I see. Okay. Anyway, we are going to remove this rotate here for now. Complete fluid speed. Accept. Oh yeah. Zero F. Use tab arrow. Enter key to make faster select. Tab. Arrow. ntar kita make voice tersirat. Pero, what do you mean? What to select? What do you mean? Yeah. Vehicle. Player controller script. Speed. Yeah. Private. If it is private, it cannot be controlled by other object. Yeah. What if it's just not public or private? I don't know. Okay lah. Public it is. Speed. Select the code to suggest. Well, I'm trying to get used to it. Shokuya, welcome. Epic. Epic game. Epic games. It jump scare. Or could you get ads because it's here from me? And your stream? Wait. My ads automator is off. Why is it automatic? Or is it refreshed? Well. YouTube, please. Don't automatic ad. I already turned it off. Adios, welcome. Welcome. Acceleration. YouTube is crazy. Speed plus acceleration. Is there max or something? Max. Not max penny. Maximum. Didn't recognize you with this avatar, only watched to see this trick. Well, you should recognize my interface on the left bottom. Is it just me or you? Voice volume is so small. It's just you maybe. For me it's open. I rarely listen to my own stream. Deal Baker, hello, welcome. Welcome. How do you my voice volume is always small compared to other. Yeah. Because I prioritize the BGM, I guess. Ah. Dash dash. Dash dash. I can listen to my own stream. I can listen to my own stream. It's just alright. Turn up the volume a bit. Entire stream setup is always small compared to others. I see, I see. Well, I don't know. The OBS isn't even maximum. I mean, like this. Look at this screen. If it goes to the red, that means it's too loud. Too loud. This one. Red is dangerous, yes. Red is ugly, no. Red is beautiful. My favorite color. Yeah. Mathematics. Double float flank. Up in. Math noise. SPTUI. Hiệu in. Love with your crush. Crush has a red helmet. Be careful not to crush the helmet. Can I sing a little? Happy birthday to you. Never mind. What is the equivalent of Kenya? Equivalent of max in CMS to Unity. Unity equivalent math.max. Yeah. It's not your birthday either. It's your sister's birthday. Grandmother's birthday. Huh? Sister's birthday and grandmother's birthday. That means Geobreaker's grandmother is long-time sister. Never mind, just kidding. Math.max. I see. So that's what I need. With f.max Speed equals speed plus acceleration. Max is 40 at 60. Acceleration 0.05. It can be something like this, like it should accelerate up to it's already so fast. Stephen, but do you ever read the Bible, Tiffany? Yes. Oh yeah, wait. No. It's not Max. It's Min. Yeah, Min. Yeah. It made that Min, not Max. Look at it accelerating. Look at this speed variable. It's increasing. Okay, good. Step complete anyway. I think I've already skipped some of the tutorials, I guess. Does that there is none? Yeah, of course. But actually, I don't really remember a lot about what's in the Bible. And I never read the English version. So if you ask me to explain the Bible in the English, I cannot. Because I never read the English Bible. Only the Indonesian Bible. Well, so I don't know how to explain in English. I mean, I never tried. Well then, welcome. Welcome.
We've added a variable to our vehicle. So if you select the vehicle in the inspector, you can see that speed variable under the script. Now when we press play, we can actually click on that speed variable, drag it, and control the speed. So we've got some good control, but our camera is still locked in the same place. So we want to make it so we can actually follow the player as they move back and forth. To do that, we'll create a new script. So underneath your assets folder in your project window, go down to scripts, right-click on scripts, create a new script. We're going to name this script follow player because this will attach to our main camera, and the behavior will be that the camera will follow the player. Make sure you name it correctly with the capital F and the capital P.
Look at this.
With no spaces.
I've already made this animation.
Follow player and drag it onto our main camera.
But I haven't done the
United. On our
United
main camera in our hierarchy,
because
you can see the follow player script has been applied as a component. So now we're going to open our follow player script by double clicking on it. So now our script has opened in our IDE, and what we're going to do is we're going to use public variables, but in a very different way this time. So what we can do is we can actually get a public variable, and what we're going to do is we're actually going to use a class or a type, in this case a game object. And so like I said before, things like our obstacle or our vehicle are game objects in our project. And so actually we can get references directly
Game
to our
object.
different game objects like our player. If we check in Unity, you can see now on our follow player script, it's added this line of code.
Game
If we
apa?
select
Driver
our main
enggak?
camera in the hierarchy,
Ini masih tutorial.
you can see that the follow player script has
Ini masih
this
tutorial
player
ini.
variable, and it's looking for a reference
Masa
to
animasi
a game
give-give yang
object
kayak
now. And so in fact, we can actually left click and
Kayak
drag
gini
our vehicle from our
masa
hierarchy
jadi driver?
into that box. And
Bukan
now
lah ya.
our player variable is
This is
tied
what
to
I
our
wanted to
vehicle.
make.
This is one way that
I mean
you
the
can get a
game.
reference to an object
This
in
is
the
just
scene
tutorial
or another object
to
to
make
use.
me
In this
used
case,
to the game
our main camera to
game
use the
developing
vehicle.
Unity.
So variables can be used in really powerful ways, not just to store numbers, but to store references to other things that already exist in our game. Now what we're gonna do is we can do a really interesting thing where we can actually get the transform. So this gets us the current transform component of the game object that this script is applied to, in this case, our camera. So we get our camera's transform, and we can actually just get its position overall. And so this will give us the X, the Y, and the Z of where our camera currently is. Now, we're going to use that equal sign, that assignment operator. We're
Player
going to
dot
set
position.
our camera's position. Now that we have a reference to our player, we can actually use player. The player also has a transform component. And we can actually get that position from
Render
the player's
transform dot
transform
position.
component. And then if we semicolon to end our
I need to
statement here,
transform
and
to
make sure we save. So now our camera's position
yeah.
will be set to
That is
the
this, yeah.
player's current position. So now, if I press play and you watch in the scene view, watch our camera and our vehicle, our camera should be set to the position of our vehicle. There you go.
Camera.
Kind of works. It's underneath the car, which
I didn't hit it.
is close enough to what we want for now. So we can watch it as it drives down the road, runs into the different boxes. Cool little perspective. So what you're gonna do is in Unity, make sure you go to your project window, right click on scripts. You're going to create
base coordinate
a new
of
script.
the
You're going to name it
of the
follow
object
player, capital F, no
is
space,
still
capital
under
P.
the current.
And then you can left click and drag it onto your main camera, or just add it as a component using that little handy button in our inspector for the main camera.
That's a good
You're
point
then
of
going
view.
to open up the follow player script by double clicking on it. In our follow player script, you're then going to create a new variable. This time it will also be public, but this time it'll be a game object variable. So that will be the type of variable that we're creating. And we're going to call it player. So that'll be the name. And then in our update method, add this line of code. So you get the
We
camera's
always try
current
to look
transform
underneath things in
position,
video games.
and you're going to set that to the current
You want to
position
look underneath
of our
me?
player's transform component. And then last but not least, a really easy step to forget is make sure you select your main camera
is
in
nothing
the hierarchy.
underneath.
In the inspector, you can see on the follow player script, there's a player variable that has no game object attached. So you're going to make sure you left click on the vehicle in your hierarchy and drag it into that box.
Makes Pyro
Then,
tomato
Player
fuzzy.
variable is assigned to the vehicle in our
She's no
Then when you
Lexius.
press play, you can watch it
Cinto
as
mama.
it drives down all the
Ding,
way
dit,
down the road.
Spyro
Now it's your
tomato
turn.
version. Flame fire spewing tomato. That will be chili. Create it. Create script. Follow player. Huh? I can access the scripts here. Tama memberi aku 3 permintaan. Nggak mau. Game object. Oh, the game object is a little bit green color. It's not so visible. How do I change the color? I forgot. Window. Tools. Customize. Cintiri. Lah kan aku nggak dari lampu. Aku kan nggak keluar dari lampu. Kamu juga nggak gosok-gosok lampunya. How do I change the color of the text? Oh no. View. How do I change color of text? They're united. In Visual Studio. Kode. CTRL-Q T or file preference system. File preferences. No preferences. Account settings. No. Edit. Environment. Fonts and color. VS Code and Visual Studio are two different programs. I see. Unreadable, I want to go to into Christian apologetics. You want to go into Christian apologetics? What do you mean? You want to confess your sin? Oh no, I don't know how to change the color of the text. Yeah, okay na. Try transform position. Hey. Huh? Ah. The editor is already knows player transform position. It already suggests. Huh. Oh well. That a suggestion for you? Uh-huh. Vehicle. How to get the vehicle? Direct the vehicle. Eh? Vehicle. Object onto the empty player variable in the inspector. You need a color extension to change those colors. PCIC. Shadi welcome. United 3D. Real engine when. Showing them of the historical reliability of the Bible, even the evidence of the supermarket miracles, and proof of the resurrection. You cannot show the proof. Forget it. Vehicle. Here. Oh yeah. Under the Karankan position transform don't campaign for referencing them. Some YouTubers have done it. Well, I don't care. You can position that way. Oh yeah. Adios, adios, thank you. Huh? Wait, how to press convert to binary. Wait, oh yeah. Float must be added with float. Float. Never mind. But they don't allow this plus equal. They don't allow that plus equal. Is this it? No. The friendly bell attack. Eventually. Huh? Tough? Wait. You smell a troll, yes? A troll, an orc. Oh yeah, what was debunking, ne? Debunking. Act of exposing or discrediting false claims. Oh. No, you don't need to do that. Bye. Just 1 minute. Also, there's a quite new account. March 25 in this year. Keep your mouse in the red line. Transform component. The kiss welcome. It's see you again. Welcome the kiss. It is not variable. Transform the position because it is not a variable. Potential fix. Copilot never met. That position. Y component of the vector. Convert to visual scripting analyzer. Equals object content. Returns true if given vector is exactly equal to this vector. Oh. Sad. New X, new Y, new Z. This is Fan. X, Y, Z. You want to do something but can't seem to figure it out. And hesitate to use Google. Common sense often doesn't work. Stop! Oh no! The camera is still under the car. Did I save? I saved, right? Plus 100 F. Plus 4 minus 5 minus 5 plus 4. It's just the same. Follow player vehicle. Why does it not? Oh yeah. But I saved this for now. In the comments. Follow new X, new Y, new Z. Hey! Oh yeah, this is player. Player dot transform. Dot position. Oh yeah. No. It doesn't move together. Is it even updated? Okay na. Let's finish the tutorial first. Add an offset to the camera position. New fractal drill. That's how you do it. I see. Huh. Yeah. Okay. Factor 3.
Our camera is now positioned Unfortunately, it positions underneath the vehicle, which is an interesting perspective, but not
Way
exactly
mas
what we're
new.
looking for. We actually want to create the same effect that we have in our camera here in our preview. So that way we're following behind the player instead of underneath the vehicle. So we'll change that perspective using some of our code. And then what we're gonna do is where we're actually setting our camera's position to
Vector
our player's
annotation is
position.
essential
This
in
is
that.
actually where we're going to add to our player's position so that
But
we can
I
offset our
already-
camera above and behind our player. Fortunately,
I've
we
already done
already
it like
did
this,
some of this
right?
work before. So luckily, the player vehicle is
Similar,
at
right?
000. And then what we did with our
Y
camera
plus
is we
4.
actually put it at
Z
5
plus
on the Y
then
and
minus
negative
5.
7 on the Z. So it went up and then it went behind our player here. So we can actually use those values to be able to reposition our camera behind the player when the game starts. So using our update method, since we're constantly keeping track of the player's position, we want to add, in this case, we just use a plus sign like you would on a calculator. And then we should add, I believe it was 0 and up 5 meters and then back 7 meters, so negative 7. So that doesn't seem to work. So let's see. I believe the problem is, so in fact, our player's position is giving us a vector 3. And here, although this would make sense in our heads, this doesn't make sense to our computer at all. Our program is trying to add some statement that doesn't exist and is trying to add it into our vector 3. So what we actually need to do is we need to add two vector 3s together. So we actually need to create a new vector 3, and we're going to use the keyword new because we're actually creating a new vector 3 instance. We're not creating a vector 3 variable that we're storing or saving. Since this is just temporary, we use new vector 3. And so now this will actually create a new vector 3 just for this line of
This
code
line of code that
that'll have the values of 0 on the X, 5 in the Y, and negative 7 on the Z. Last but not least, we're going to add a comment to our code. So we're going to say offset the camera behind the player by adding to the player's
the players.
position. Now we make sure we save. So now if we test our game, we should see that our camera is just following the vehicle. Awesome. So now we have a much better view of where we're driving and where we're going. So what you're gonna do is in your camera's position, where you set it to be the player's position, you're just going to add a new vector 3 with the values of 0, 5, and negative 7. Now it's your turn.
Yeah. What I did was using this set position set what if I do it this like this plus new vector 3 yes error oh yeah corrected no what I cannot use set for this equals pembuat What's this? Again. Never mind. The set doesn't seem to be working as I wanted. It's not to set the position. Yeah, working exactly as advertised. And went to the flood. Into the flood. How about you transform set position? Set position and rotation. Yeah. Vector 3 position. Quarter neon. That's what Peanut said. Water neon. It just made it up. There's only set position and rotation. Local. Oh yeah. But that also makes sense. Water neon. Offset into the vector 3 variable. We may want to change it later. Vector 3 offset.
Now our camera is positioned perfectly behind our vehicle as it drives down the scene.
Vector is the
What we're going to do
character
is we're
from
just going
the
to clean
speak
up our
completely.
code just a little bit to make it easier to understand. In our follow
Experienced
player
Unity
script,
developer
I mentioned that it's really
and
bad
ask
to
what
have
these are
hard-coded
quaternion.
values. So we're actually going to take this vector
Chances
3
Andy
we
would
created
say.
and create
I
a
don't
variable
know.
for it. So this one will make
I
a
see.
private variable, so it can only be used inside of this class. So I'm just going to use the keyword private here, so you can see how it's used. Very similar to a public variable. And for this, because we're making a vector 3, we need to make this variable a
You
type
don't know
of
either.
vector 3, and we'll call it the offset. Now we set this variable to be this value here. So in fact, we can just cut by Control or Command X with the code highlighted, and then we go to where we had the offset, and we paste with Control or Command V. So now our offset vector variable
doesn't know when
is
he's
being
working
set
for
to
the
that
strongest
new
Korean company.
vector that we made before
Game company.
with our offset position
I see.
already added to it. So now, in our update method, we can just add where we removed that bit of code, the word offset, and because offset is a vector 3 being added onto a vector 3, then we can set our position properly. Make sure you save, go back
Private.
into Unity, and press
Why must
play,
it
and
private?
you should see that nothing has changed, which is exactly what we wanted to happen.
I want to change the offset.
So, what you're gonna do is in your follow player script, you're gonna create some of variables of your own. You're going to make a private vector 3 variable called offset, and you're going to initialize it by assigning it that new vector 3 offset that we had created down in our update method. And then you're going to remove that new vector 3 line and just replace it with the word offset. So that way, it's always just using the offset variable, and if we ever need to change our offset numbers, we can just do that here at the top of our code. And then just make sure that you press play and test to see that it's working exactly like it should. Now it's your turn.
New factor 3 of chat. Factor 3 factor of chat. Wait.
It's working exactly variable and
Game object player. Merush. Oh yeah. I should make it more similar. Oh yeah. Smooth the camera with late update. Replace update with late update. Notice the jittering camera. Oh. Yeah. So the player position updates after the camera. So we want to update the camera later than the player, so that the position is correctly to the player, to the current position of the player. So you just remove and replace it with let update.
Okay, now that we have our camera following our vehicle properly, you might notice that there's a weird effect happening with the vehicle itself where it's kind of stuttering back and forth. And so we can make one small change to our follow player script to make our vehicle move super smoothly. Now, essentially what's happening is, in our update method, our vehicle and our camera are both moving at the same time. So sometimes the vehicle might move first, and then the camera might move, but other times, the camera might move and then the vehicle move, and so it creates this stuttering effect. A simple thing that we can do with our update method is change it to late update with a capital L, make sure there's no space, so it's all one word. And with this late update method, essentially what it will do is update after our update method happens. So if you remember, for our vehicle, it's moving through the update method, constantly moving forward, and then late update is called, which will then move our camera after the vehicle is moved. So if I save this script using Control S or Command S on a Mac, head back over to Unity, and then test out our script to see if it works, we'll press play, and you can see now that the vehicle is moving much smoother because of that late update method, where the vehicle moves first, and then late update happens, making the camera move to follow the vehicle. So what you're going to do is head into your follow player script, and where update is, we're going to change that to late update with a capital L and a capital U, no space, so it's all one word. Once you've changed update to late update, make sure to save your script using Control or Command S, head back into Unity and test out your project using the play button, and you should no longer see your vehicle stuttering in your camera frame.
Wait, update. Yeah. That should be already okay. Damn, that's cool. You never knew about it. Huh? Wait. Even you never knew about it? Don't lie. You already went to the tutorial, right? You just forget maybe? I did a play mode thing color. Colors? Colors?
our camera is now well set up in our game to be behind the player, and we even added in some variables to make our code more organized. Now we're actually going to fiddle around with our Unity interface again, just like we changed the layout, but this time with a very helpful tip to know when you're playing your game. So you can see when you play the game, your interface goes from a light gray to a dark gray.
Oh, you like
Which
because you
is
mimic
helpful,
long?
but not entirely
I
visible.
see.
So I'm going to show you a cool little trick that I do, so it's really easy for me to know when I'm in play mode. At the very top left of Unity, there's an edit button. If you're on Mac, there will be a Unity button, and then you click Settings. From my edit menu, I have a Preferences option as well.
Edit preferences.
Now, in our preferences, we have all of these different options. Right now we're on General. There's one down here called Colors, and specifically, there's an option here called Play Mode Tint. So this is actually what controls the tint of our interface when we're in play mode. So if I select this by clicking on it, you see it brings up a color picker. So you can pick colors yourself, you can move it around, you can change the opacity so that it's more clear, or if you want it to be really dark and really visible, entirely up to you. So I have a setting that I like to use, so I'm just going to type in values for myself. So 157, 194, 239, and then we'll make this like 150. So now I should have a fairly transparent light blue. So I can close out of my preferences. You can see that it actually saves it immediately when you set that color. Close out of the preferences. Now when I press play, you should see a bluish tint pop up over all of my window. So that's super helpful. So now I know when I'm editing values, if I'm in play mode or if I'm in my scene. And so that way I don't accidentally change something that just gets reset and then I don't remember what the value is. So very helpful tip, just something to make your life a little bit easier as you're testing your game out and trying to figure out why, for example, if you click on something, it's not moving or whatever. So what you're going to do is in the top left of your editor, you're going to see an edit or a Unity button. Click on that. Go down to preferences, click on that. You'll see this preferences window pop up.
Genetic kind of thing
You can
whenever
click on the colors option.
run my games.
Under the colors,
I see,
under
I
general
see.
should be play mode tint. If you click on that, you can select different colors. You can change the opacity. And then when you exit, it saves your color. You can exit out of preferences. So then when you play your game, you can see when you've entered play mode, which is really handy. So now it's your turn.
It's already tinted. Technically, it's already tinted. I'll watch it again. Allah, which one? Already forgot the actually has a tutorial. Oh no, I already forgot which one is for the tinting. Oh, colors here. Colors. The setting a color with 0 and 5, you can actually make your like multi-unity disappear. Play more than alpha 0. Where is the stop button? Where is the stop button? Oh yeah. Okay lah. Nah, don't make it transparent. This, okay. Yeah, this is better. Don't make them transparent. Complete. Variable data text. Text modifier saya. Float FM. Yeah. Floaty. Complete. EXP get. Clear instructions. Step into the driver's seat. To detect when the player is pressing the arrow keys. Then accelerate, then turn the vehicle based on that input. Oh yes, finally. Finally the input.
The vehicle in our prototype is currently a very low-end, very dangerous self-driving car. You click run and the car rockets off on its own, crashing into every obstacle along the way. Not necessarily the kind of car you'd want to be a passenger in. So it's about time we let the player step into the driver's seat and take the wheel. By the end of this lesson, the player will be able to control the acceleration and direction of the vehicle using the arrow keys on the keyboard. The vehicle should move forward when the up arrow key is pressed and backwards when the down arrow key is pressed. Luckily, Unity has an entire input system set up to help us do exactly that. When you press the up arrow, you get an input value of +1, and when you press the down arrow, you get an input value of -1. So let's say we set the vehicle speed to 10. All you have to do is multiply that speed by the input value and you're good to go. When the player presses the up arrow, it'll multiply 10 by +1, giving you +10, moving that vehicle in the positive forward direction. But if they press the down arrow, it'll multiply 10 by -1, giving you -10, moving the vehicle in the negative backward direction.
Oh yeah?
Then you can basically use the same type of system to rotate the vehicle. You multiply the rotation by a positive value if they press the right arrow, turning the vehicle right, and multiply by a negative value if they press the left arrow, turning the vehicle left. Just some simple multiplication, and you've got full control of this vehicle. So to make all that happen, I'll see you in Unity.
Project settings for the input system. There is no one talking. Input system package. Buat. Input system package. What was he thinking? Edit. Project settings. Player. Input system. Where was it again? It was Visual Studio. Did I choose? Preferences player, no? There is no player. It has to be because the video was remade to fit with the newer version of Unity nowadays. Unity. But did project settings. Oh yeah, project settings. Not preferences view. Oh yeah. Player. Other settings. Active input handling. Boot. Apply. Got these two mixed up all the time. The student is not paying attention to the class. That's it. Yeah. I see. Okay. It's finished. Automatically restart. Why do I need to change this? I wonder. Preferences means general settings applied to the Unity editor. Project settings are project specific. The input system is different for each project. Allow the vehicle to move left or right.
As in our previous video, now we can use the speed variable to speed or slow down the vehicle that we have, or use the turn speed variable to move left and right. But there's actually no way for us to control that
It's different
with
person.
button presses or key presses.
The
that
voice
you might
is
need,
different.
as with any game where you might need controller support or mouse and keyboard support. Now today we're going to use the newer input system, which allows us to expose a move action so we can bind different keys to it. And we're going to make that visible in the inspector so we can add those bindings that we need so we can start using button presses and loads of cool things within Unity. So
But
first
we
of all, we
love
need to
Cody.
open up the player
I don't know.
controller script. And we're going to add ourselves a new variable, which will be acting as our move action.
Turn
So
speed.
it's going to be another public variable, but in this case, instead of it being a type of float or something like that, we're going to name it input action. And this uses Unity's newer input system. Now if I press tab to autocomplete, it may well add something to the top, which you may have noticed, which is called using Unity engine.input system. But we'll come back to that just after we've named our variable. What I want to name that is something like move action, and make sure to add a semicolon on the end to close it off. And with your name,
Input
move
action.
action, you need to remember that move should have a lowercase m at the start, and action should be uppercase, just like the rest of our variables, just to
Move
keep it nice
action.
and consistent. Now to go back to that namespace that was created, you can see at the top. If I remove that and get rid of it, you may well get a squiggly line or some kind of error in the console which shows that this is missing. Now if I hover over it, I'll say that the namespace is missing, so it doesn't understand what this means. If we go and show potential fixes, it will show using Unity Engine.input system as a suggestion. We can select that by double clicking and it will add it to the line at the top. You can add this manually, but you need to make sure that this is case sensitive. So you spell it Unity Engine .input system with also 2 capitals at the beginning. Now what we can do is save out that script. Now if we head back into Unity and make sure our vehicle is selected, you can see on this right hand side in the player controller, you can see that we've got the speed variable, the turn variable, and now we've got a move action. And this has some buttons that we can select and start adding our own bindings, which we will in the next video. But for some reason, if that namespace never existed, you can head to edit, you can scroll down to project settings. If on the left hand side you navigate to player, you scroll down this page a little bit, halfway down, you will see something called active input handling. This should be the input system package new. If not, make sure to select it, or you can have both selected if you wish. If you're using the older input system, make sure you restart Unity after that to make sure that you make those changes apparent. So just to recap, like I said, I want you to be able to create a public variable with a type input action and give it a name of move action like we discussed, and make sure that you're using the input system namespace at the very top of the script to make sure that is all working correctly. And in Unity you should be able to see the move action variable appeared in the inspector.
Now it's your turn. He doesn't say that. The idea of him getting laid off is gratuity shipping in German. Thought your voice had become quite deep. Always from? Yeah, it was tutorial. But then no tutorial, do you? Okay. Scripts. Player control. Rotate. Oh yeah. Wait. Transform, transfix. Time delta 10 turn speed. Turn speed. If to the right it's plus. Yeah. Turn speed. Move action. Oh yeah. Love X. Then put action. What is that for a phone now? Maybe later. Huh? Wait. Transform? Translate? Huh? Translate? Translate is not rotate. Huh? Allow the vehicle to move left, right. Ah, yeah, it's not move. And it's not rotate. It's move, oh yeah. Huh? Able to move left and right. I don't need to move it. I already know the rotate.
In the previous video, we looked at adding the move action variable so we could map different buttons to the action. Now we're going to look at adding a 2D vector composite so that our move action can then bind WASD or any other keys that you might want to use. I'll also explain about vector 2D and how that relates to vector 3 in terms of movement so you get a full understanding of what you need to know. In the player controller component and the move action variable that we have some buttons on this right hand side. You can see the little plus icon here. You can see it's got a bunch of different options that we can create for controlling the binding. Now, to be able to create something nice and easily for our WASD or even arrow keys, we want to add an up, down, left and right composite. If you click that, it will add a 2D vector component, and you can see that you can open and collapse this, and it has binding options for up, down, left and right. Just to note that if you ever want to remove any of these bindings, if you've created one by accident, you can click on the 2D vector and just press the delete selection so you can remove that. So I'm going to try and help you understand what a 2D vector is and how that relates to 3D. I want to be able to explain what WASD means and how you can use that. When we press W, we want to move forward. If we press S, we want to move backwards. And if we want to press A or D, we can move left or right. So Unity needs to combine all 4 of these buttons into one direction value, and that's what the 2D vector composite actually does. So in plain English, the vector 2 is 2 numbers, X and Y. X is left and right, and Y is forwards and backwards. If I display this another way of how it would output for each button, W is 0 and 1, S is 0 and -1, because it needs to go backwards. A is -1 because we need to go left, and D is +1 because we need to go right. And just as a quick note, if you're interested, when you've got keyboard versus controller, keyboard values can be -1, 0 or +1, because you imagine you'll need to be able to go left, right, or no right at all. And in joystick, values are smooth because you can almost go in any direction at any point. So in that idea, that the exact same move action can work with both keyboard and joystick. Now in the inspector in Unity where we had the vector 2, you do see the up binding. If we double click that, you can head to the path, and if we click on that path area, you can either type or you can listen. I'll show you how you can do for typing. So if we want to go up, we want to press the W key. It will give us a full list of all the different buttons that might exist in this input system. But in this case, we just wanted W on the keyboard, so we can click that and add it. As you can see now, up has the W key on the keyboard. Now for down, we can double click that again, head to the path, and if we click listen, and then listen is specifically for listening for a key, whether it's on a mouse, a keyboard, anywhere. Now if we press the key that we're looking for, so down should be S, it will find that key that specifically we just pressed. So S on the keyboard, it knew without finding a full list. For left, we could do the same thing. We can go to the path, listen, press A, we know that it's A on the keyboard, and the same thing for right, we'll go to the path, click listen, and press D, and we know D on the keyboard is the right also. Let's say you've added W, S, A, and D, but you wanted to add arrow keys as well. You can click the little plus, add a up, down, left, right composite, and you can see we've added another one, so we can have another selection of keys. In this case, we can go up again, double click the binding, and I'll find the up arrow. We can click down, find the path, listen, and I can press down for down, and left, listen, go to left for the left arrow, and right, find the path, listen, and press right on the keyboard to get the right arrow. So we have a selection of different buttons that we can easily have mapped, ready for players to use. So as a quick recap, what I want you to be able to do is find the move action variable within the player controller script, click plus to add a brand new up, down, left, right composite. This will add our 2D vector, and you'll see it will have binding options for up, down, left and right. You can choose this, you can either have the up arrows or the W, S, A and D keys, but you can click on any of these options and associate them with the movement keys that you want to use. So fundamentally, as the example for up, you can click on the path, listen, press our W, and that's what we want to do for our up movement. So you can repeat that for any other binding that you might want to use.
With the giant changes in the input system and Betty's voice isn't going back to the tutorial anytime soon. So there was another tutorial before this because the input system is already changed. Move action. Up, down, left, right composite. 5D. Game back to stick. Keyboard, mouse keyboard. Character left key. Listen. Yes. Yeah, okay. Two factor, 3D factor. Huh? Oh yeah. I don't left, right. Forward, backward. We don't need them 3D factor. For now. Good night, kuya. Bye, Corona. See you. To Adios. Input system is already there, even before I added it. Input system. Assign bindings with the action.
So in the previous video we had the 2D vector for the W, S, A, and D, and if you added the arrow keys as an example. And we need to be able to...
Wait. They're for good, Dad. I can add one more. Up arrow. Down arrow. Left arrow. Right arrow.
Now use this to read that move action as the vector2 and expose that in the inspector so we can test this out in play mode to give you a better example of what they do when we press these buttons. If we open up our player controller script, we're going to start by adding a new variable to the top of our script, which will be a vector2 so we can watch those button presses in the inspector. So underneath our input action, what we want to do is add another public variable, but in this case have this as vector2 because that was for our input bindings, for left, right, back or forward, and then we're going to give this a name of move input and make sure you add a semicolon on the end. Remember that the M in move should be lowercase and the I in input should be uppercase, so we're nice and consistent. Now in Unity's newer input system, we need to make sure that we enable any action that we do, so it starts listening for the buttons that we might press. So in our start method we can do this, because if you remember the start method is something that happens as soon as our game launches. So as soon as our game starts, the start method runs any lines of code that it has in it, and it's done before anything else, so it's great for initialization. So in our case, what we want to do is do move action dot enable with a capital E, then open and close the parentheses and put a semicolon, and that just means that our action is enabled and ready to be used. I just wanted to make a note that if you want to be really optimized, you can have a method called avoid on enable, and this is just a method that can be used, as it says, to be able to be called when an object becomes enabled or active. So you could take this line here and add it in there if you wish. But we'll leave it in the start method for the consistency of this tutorial, but keep that in mind for the future. Now we need to make sure that this updates in the inspector, but it won't do that by itself. We need to add it to the update method, which is called every single frame, which is great for input because you might be pressing input at any time. So what we can do there is make sure that we add our move input variable, set that equal to our move action that we just enabled, right dot read value, and then next to that we're going to open and close angled brackets. So angled brackets left and angled brackets right, and then within there we'll write vector2, and then at the end we make sure that we open and close the parentheses and add a semicolon. What we're doing is we're updating this variable all the time with what the value of move action is, and it's passing in a vector2 which we already knew that we were using. Now if you save this script out, now if you select your vehicle object, head to the inspector and you can see the player controller script again. You see below your move action you'll have something called move input, and you'll see X is 0 and Y is 0. So now when we test this out, you may want to click on your game view because it may not update in the inspector if you're not careful. But if we press the A key, you can see that X goes to -1. We press the D key, then X goes to +1. And then if we press the W key, Y goes to 1. If we let go and use the S key, you can see that Y goes to -1. So all these together, you can start seeing what the values of each of those inputs are. And we will be able to use this move input value within our translate to make sure that we can then move the vehicle forwards or backwards and left and right. So as a quick recap, what I want you to be able to do is add a public vector2 of name move input, because that's going to be something that holds the vector2 information for our input presses. Then in the start method, you can have move action.enable, which enables the inputs to be able to start being read. And further down in our update method, we're using the move input that we wanted to give information to, and then we're updating this move input variable with the value of move action, which is a vector 2, just like we saw in the inspector. And then we can begin to use this within our movement to make this happen.
Balls. I forgot. Oh yeah. I thought to move input. Move action. Look, move action. Enable. The rotation is in this right. X, Y, X, Y. X. Yeah. Yep. Ah yeah, is this the same right? Oh. Ah yeah. Yeah. Announce. Speak. We'll just get this for now. Does this actually work? Move input. No action. Get with this. Value, what was it? What was it again? Yeah. Read value. Oh yeah, read value. Read value. vector 2. Plus action narration times. Helping part way. No error. I must grab them. Huh? I must grab them with brackets. Huh? Follow C. Acceleration of input way. Tagline with rain antenna. Flat underline. Oh yeah. Only assignment call can be used as a statement. Kecuali tab. Up to. Pineapple. Enough action pineapple. I need the brackets. I need the brackets. They are so inconvenient. Even though the bracket is empty, I must still use them. There. Sakuro irashai. Irashaimasu. Irashaimasu desu. Masu desu. 難しいことやってる？はいです。Oh look, I've already made it. But the rotation... was... Never mind. I've already done the movement part. But the input values. No input.
So in the previous video we had the 2D vector
Making us bold
for
now.
the W, S, A and D, and if you added the arrow keys as an example. And we need to be able to now use this to read that move action as the vector 2 and expose that in the inspector, so we can test this out in play mode to give you a better example of what they do when we press these buttons. If we open up our player controller script, we're going to start by adding a new variable to the top of our script, which will be a vector 2, so we can watch those button presses in the inspector. So underneath our input action, what we want to do is add another public variable, but in this case have this as vector 2 because that was for our input bindings for left, right, back or forward. And then we're going to give this a name of move input and make sure you add a semicolon
This is the
at
same
the
thing.
end. Remember that the M in move should be lowercase, and the I in input should be uppercase, so we're nice and consistent. Now, in Unity's new input system, we need to make sure that we enable any action that we do, so it starts listening for buttons that we might press. So in our start method, we can do this, because if you remember, the start method is something that happens as soon as our game launches. So as soon as our game starts, the start method runs any lines of code that it has in it, and it's done before anything else. It's great for initialization. So in our case, what we want to do is do move action dot enable with a capital E, then open and close the parentheses and put a semicolon. And that just means our action is enabled and ready to be used. I just want to make a note that if you want to be really optimized, you can have a method called void or enable, and this is just a method that can be used, as it says, to be able to be called when an object becomes enabled or active. So you can take this line here and add it in there if you wish. But we'll leave it in the start method for the consistency of this tutorial, but keep that in mind for the future. Now into angle brackets. You want to click on your game view because it may not update in the inspector if you're not careful, but if we press the A key, you can see that X goes to -1. We press the D key, then X goes to a +1, and then we press the W key, Y goes to 1. If we let go and use the S key, you can see that Y goes to -1. So all this together, you can start seeing what the values of each of those is. Then in the start method, you can have move action dot enable, which enables the inputs to be able to start being read in the inspector, and then we can begin to use them.
And the vehicle turn instead of sliding. I already done that. Sorry, but I've already done that.
In our previous video, we added the input for mouse input for X and Y, so we'll be able to control our vehicle now with WASD. But now we actually want to make sure that when we press A and D, when we move left and right, we want to be able to rotate in that direction, just to make things look a little bit more realistic.
That doesn't look intuitive at all.
Like it makes much sense. So I want to head back into the player control script, and we're going to add a new line to be able to make this happen. So I want you to navigate to the object method, and where we have the move vehicle left and right, this line here we transformed at translate vector 3 right. What we're going to do is we're going to leave this for now. I'm just going to add a line above this, and we'll talk it through as we go. Now we're going to want to use transform again, but in this time we want to use rotate with a capital. This just means that we can use it to rotate around a specific local axis that we want to use. So if we finish off and do transform.rotate, we'll open up the brackets, and this time we'll use vector 3 as we did before. Then we'll say
Vector
dot
3
which will
up.
help us spin the object around the local y-axis. Then we're going to have a comma and use timer.delta timer again to make sure this is frame rate independent. And we'll have a multiply symbol, again the turn speed, multiplied by the move input.
何かやりたいことがあって、
So you can see in this example,
勉強してるの？
the axis that we want, and an angle.
ゲームを
This is the local y-axis, and this is the angle that we want to do
Unity
based on
で
independence, turn speed, and
ゲー
the
ムを作ろうよ。
Just before we delete this translate line, because we don't really need it anymore, I want to just compare the two and tell you the similarities and tell you the differences. The key
前
difference
は
is
ね、
we
ゲーム
can
メー
translate
カー
and
ス
we
タ
can
ジオ
rotate. So we rotate, the object always stays in the same position, but it only
で
changes its
やっ
direction.
て
So
た
you can get that look of being able to rotate left
け
and
ど
right, whereas translate actually moves the object's position. So it makes it
今は
easier to translate
Unity で
straight.
やり
So
たい
rotate in this case is the best thing to use. And then we should still have a
です。
line which is the transform.translate. I want you to just completely remove that line because it's not relevant for this anymore. And then we're going to choose to save out this script, and then if we head back into Unity, and then what I recommend to do when you look at the player controller, I've set my speed to 25 and the turn speed to around 70 just to make it feel more responsive. Now when we test out our game, we can still press W and S to move forward and back, but now you can use A and D to move left and right. If you try and control your vehicle, you can now try and avoid these obstacles depending on the speeds that you've got, and move
No,
more
they
realistically
make
with your
it
controlled character. So just to recap, make sure you head to the
without
player controller script, and in
acceleration.
your update method, then we want to add brand new line of code.
That's
which
not
starts with
guys
transform,
like
and then we'll have dot rotate. Remember the rotate has a capital.
at
We open the brackets
all.
and have vector 3 dot up, which is the axis that we want to use. Then we put a comma and specify the angle that we want to move by. So we'll say time dot delta sign times the turn speed
Okay
times
lah.
move input dot x, which will give us a smoother rotation that we're looking for.
Turn speed. Yeah, okay. I've already done that anyway. Skip. Skip ya. I've already done a better version of this tutorial because I added acceleration. Linear content and hierarchy.
In our previous video, we looked at being able to add rotate to our code just so that we could control our vehicle
Use
more
add
easily to
comment
be able to move around and control our
change
character.
move
Now, when we
input
come to create anything in Unity,
to a
if you want to
private
pass
field.
your code or pass your project to somebody else, it's good to try and keep everything readable with comments so you can explain exactly what the code is, and it can even remind you
In
what
doing
you might
good
need to
debate,
do
it's
if you
good to
come back
train your
it
stuff on
another
your own
time. So we're going to go back
see
to
how
our
things
player
work, yes.
controller script, and we're going to add some comments. So you can see at the top here, we had our public float with the speed and turn speed. We're going to add 2 slashes above the variables, and we can just write movement tuning, something like this. And we
Movement
can just say
tuning.
this is editable in the inspector, just to keep a nice note for that.
Editable in
Underneath here,
inspector.
where we had the input action, We could write another comment saying that the input system action
For
exposing
binding.
the inspector for bindings for WASD. Now, to maintain this code and give best practices, this
Okay.
variable doesn't need to be in public anymore because it's something that we
It's
don't
just
need to
making them
by
tidier.
We can now make
I
this
will
private.
do them
So we
on
create
my
ourselves
own.
another comment, which is the current input value, x equals
Later.
left and right, y equals forward and back, and kept private for internal use.
In
Just
my
make it
own
make sense.
project.
We can keep this comment here because it's created automatically. And we create a separate
Don't
user.
tell me
You
to
may want to comment
tidy.
inside of this start method about the move action dot
We
enable.
have to make
And
the
we can have
tutorial
enable
project
move action,
tidy.
so it starts reading the input. You can leave the update comment or delete this, depending it's up to you. We can have another comment for the move input, which reads the 2D vector from the move action. X is horizontal and Y is vertical. We can update this comment, which is already here. So now we can say move forward or back along the local Z-axis using the Y component. Just to give us as much explanation as we need. for this
Yeah,
particular
skip
line of
lah,
code.
skip.
And the last one we can update this.
Skip. I will make my own project tidy later. Okay, complete this tutorial. How would you rate this tutorial? 4 stars. A instructor is different. Different. Nah, ya oke lah. Pulling programming. Challenge 1. Pulling programming. Fly upwind.
Welcome to your very first challenge.
Yay, welcome back.
In these challenges, you'll be given a
Welcome back.
new project, but it will be filled with bugs that you'll have to fix and missing features that you'll have to implement. The goal here is to take the skills you learned in the unit and put them to the test in a different environment. For example, in the first unit, you learned to program a car that could drive down a road. In this challenge, though, you're not going to program a car, you'll program a plane.
A plane.
And this plane is going to come with all kinds of issues. It flies backwards instead of forwards, you can't steer it, and it goes like 1,000,000 miles an hour just in circles. It's basically a nightmare, and you are in charge of fixing it. Don't worry though, if you think about it, the programming required to steer a plane is not too different from the programming you did to steer that car. You know how to make objects move forward, you know how to rotate them based on user input. That's pretty much
It's only
all
the
you'll need to
overview.
know to program this plane. Plus, you can always reference the code from your prototype. And we've also provided you with some helpful hints if you get stuck. In addition to the main challenges, you'll also have the option of completing bonus challenges.
Bonus challenges.
These bonus challenges require you to go just a bit above and beyond
I already
what you
done
learned
that.
in the unit and apply your
Above and
skills
beyond.
in completely new ways.
The
You may even have
acceleration.
to do a bit of online research to figure these out. So if you do complete a bonus challenge, you should give yourself a pat on the back. Now, during these challenges, you may be tempted to throw up your hands and quit. They're not easy, but my advice, don't give up.
Don't give
If you
up.
take the time to troubleshoot the issues and work
I
through
don't wanna
these
give you
challenges,
up.
your Unity
I
and
never
programming
give you up.
skills will be at a new level when you get to the other side. So to make all that happen, I'll see you in Unity.
I'll never give you up. Never gonna let you down. Eh. Different notes, I guess. Challenge 1 starter files.
Welcome to Challenge 1. Now, if you remember in our first project that we made, we added a lot of functionality to our project with this
Oh, yeah?
vehicle that can drive forward and these boxes
In
that
like
have
the
physics and collisions in it, and we can fully control this
Like
vehicle,
cakes.
turning it left and right, driving it forwards, driving it backwards. So, for our first challenge, you can see that we have this plane flying game, and if I use the arrow keys, I can control it going up and down. Our plane is flying forwards at a nice, consistent speed. We have our camera over on this nice side view so we can see our plane flying around and we can fly through all these obstacles, and we're following the plane really nicely. So, this is what our challenge should look like by the end. And this is what our project looks like now. Oh my gosh, the plane just flew straight backwards. It's like, it just keeps going incredibly fast. That's far too fast for us to be able to do anything. Oh my gosh, just flying straight up all the way directly into the air. Well, that's not good. Can I even control this? No. That's really frustrating. For some reason, our camera also has this weird front view, and it doesn't even look like we're following the plane at all. I don't even know where the plane is. It's gone. That's frustrating. Okay. Now, on our challenge page, below the video, you can see that there's all of these different steps that we can go through to make our project complete. You can see here listed the entire step that you have to do. So the problem is the plane is going backwards. What we need to do is make the plane go forwards. And if you get stuck, there are these helpful hints at the bottom to help provide you with a little bit of insight as to how you can fix the problem in case you get stuck. Our next step, the plane is going too fast, so we need to slow it down. The camera is in front of the plane, so we need to reposition it. Our camera is also not following the plane at all, which isn't very helpful. And our plane is tilting automatically. So, in order to get our project to a complete state, we need to make sure that we go through each of these different steps. And something helpful that you can do as you complete each one, for example, if you finish watching this video, you can mark the step as completed. And then if you fix the plane going backwards, you can mark it as complete. If you found you actually broke something, you can mark it as incomplete so you can keep track of your progress. In addition to our main problems with our project, we've also added in bonus challenge problems that you can try and solve to see what you understand about Unity and push your knowledge just a little bit further. So, in our completed project, you can see if I press play, and then I'll just pause this game really quick. And then actually if I go focus in on the player, get it to the side, I'm going to step through, and if you watch the propeller, you'll see that the propeller actually rotates as the game is playing. So that's a cool, fun little feature that you can try and do yourself. The bonus challenges are designed to be a bit more difficult than what you know and understand. There are hints that help you along the way in case you want to give it a try and see what you can do. In addition, if you do get stuck, feel free to use the internet. There are so many different resources that you can use just looking it up on Google. So for example, if I want to figure out how I can make an object rotate in Unity, there's a little tutorial that you could do for spinning a cube that's very similar. Somebody asked a question on Stack Overflow about rotating an object that might have some good advice on how you should approach it. This is kind of an interesting one. How do I rotate an object around its center in a script? Very similar to what you're trying to do. In addition, these challenges are also a great opportunity to take a look at the documentation. So here is actually the documentation about how transform.rotate works. That goes in depth about all of the different ways that you can use the rotate tool and the rotate method. It even has some examples that you can take a look at. So if you want to see different ways that you can rotate something,
See you
it's a good
next
place
time.
to go. And you can also see all of the other different options. For example, vector 3, of all of the different vector 3s that you could potentially use. So that way, you can start digging a little bit more into all of the different ways that you can use all of the different methods and the different classes in Unity to be able to create your projects. Now, if you do get stuck, inside of your challenge folder, there's a set of instructions that you can use. And inside of the instructions, if we click on the challenge 1 outcome, and in fact, in our inspector, you can see this little gray bar down here. And if we actually just drag this up by clicking on that gray bar, you can see there's actually this little video, and if you press the play button, you can see exactly how we were trying to make our plane and our game work before. Now, a lot of the things we were trying to do before are very similar to how we set up our initial project that we made, our prototype 1. So if you ever get confused or get lost, you can feel free to reference your prototype, take a look at your scripts, see the different things that we set up in our scripts to understand what's going wrong inside of our challenges. Another really helpful thing in our challenges is in the scripts folder. All of the scripts actually have an X at the end of the name, so that way you know that this is our challenge script versus the names of the scripts that we had before.
To get started, download the challenge assets using the link below the video.
It will prompt you to download your challenge file, and then if you want to add that asset package to your project, you can go to the top left of Unity, click the Assets button, Import Package, Custom Package, which will then bring up your File Explorer, and then just go to the folder where you have that package saved, click on it, click Open, click on the Import button when it gives you the prompt on the window, and it will download that package to your project. So, get started on your first challenge, and good luck.
Oh. Is this the same project? Ano nga? Okay na. Would you welcome? Welcome, welcome. You're cute, thank you. Thank you, thank you. Welcome to the stream. The challenge of to mend this better. Connect on bank, welcome. Why to mend this better? It's not like it's Shiok sound. Or maybe the Hollow Knight. What was it? What was the last? Oh no, I forgot the name. The Trios in the Hollow Knight where you fight all of the bosses. I forgot. Dan masih fokus mengoding saat malam hari. Hayaw. Source files. Lighting data. Reflection. Reflection broke. Materials. Black reader. Instructions. Outcome. Scripts. One player X. Way. Where is the alien? Planes are small plane. Drawing. What do I need to do? Instructions. It is supposed to have bugs. The purpose of the challenge is for you to fix those bugs, which are listed below. There are also hints at the bottom of the page to help you if you get stuck and wish to delete the challenge files from your project in the project window. Right-click challenge 1, then that good luck. Oh yeah, the plan is going backward. Make the plan go forward. Then I change. Can I just change this? Do you let me go with this and change this? Can I change the under the object? FIFA couldn't. Oh yeah, this one. Replace. Replace and keep operates. Oh yeah. No, the plane is going down. Okay, nah. Plane. Smaller plane. Let's just rename it again. So this grid. Player controller. Player controller X. How to change the way it shows the scripts? I wanted to show just the file name or something. kolong layout. I don't know. Okay lah. Final player X. Player controller X. I cannot test things. Script. Player controller X. This one. There's a remote light. Camera. Remove this. Add the script. Follow player X. Player controller. One was the challenge. The plane is going backward. Translate. Back zone. Extension. Forward dia. Yeah. Let me just do that. The back one. No. We should make no graffiti. We should have this without graffiti. 1A 1B07. What is that? Use graffiti. Oh yeah. Huh? Follow player. Game object blink. Wait, blink. Yeah. The plane is going backward. I cannot even see it backward. Because the camera. Vector string. X, Y, Z. First thing first. We it doesn't show the blink. Kembali ulit. Is to like what should I have this? Update to the current position in the stat for the offset. You bet those three. No. When transform position minus transform position. The strongest programmer is the one who ate the most bugs. Oh yeah. Oh. So that's why. That's why you said. I mean, you used the worm emote. I see. Wait. Oh, chat is dead. It's a chat from the editor. Okay, good. This looks like the editor. I don't need to read the offset on my own. Okay. Layer controller. Input get axis vertical. This one is different from that non-intuitive one. Get axis. Yeah. That's the old input system. The vertical input is working okay, but it doesn't move at all. Oh yeah, speed. The speed is not even done. The speed is not even done. Okay. Galaxies. Vertical. Fixed update. Fixed frame rate frame. If the mono behavior is enabled. Speed. Oh yeah. It's already like that. Moving pembuat, yeah. And then we finish with that forward. Complete. Going too fast. I will just let it be complete. The old time. Rồi. Tilting automatically. Make the plane only. Tilt only if the user presses up or down. We change this to rotate. And rotate. Vector 3. Adios. Oh yeah, I can have this I'm direct instead. Rotation speed. Oh yeah, it's already suggested. Rotate. What is the tilting again? Y? No, yeah, X. Yeah, X is the tilting. Plus is down. Minus is tilting up. Minus. X. X. X from the vector is left, right? Minus 1. Tilt the plane based on up-down arrow keys. Oh yeah, this one is already correct. Vertical input goes here instead. It will stay. Yeah. It's tilting, right? But it's too slow. Again. I forgot about dinner that house did. Yeah, it's rotating and tilting. Tilting. Wait. So the plane is tilting automatically. No, it wasn't. It wasn't. We didn't even have the script to automatically tilt it. Camera is in front of the plane. I already fixed that. The camera is not following the plane. Already fixed. The plane's propeller does not spin. Oh yeah, by the way, open the propender. The plane has propender. Vehicle and propeller. The propender is the child. Have I made any progress? Yes. I've already done the tilting thing. Only the plane propeller. Although I don't know why the tutorial doesn't look like the overview. Should do it overview.
Above and beyond. But we've it's backwards instead of forwards.
That one, right? When I import this, it doesn't really look like it. I don't know. I'm just lazy to reproduce it. Also, this propeller. I must rotate the set. Does the package have any differences? Challenge. Instructions. Scripts. Source files. Materials selecting data. No, there is no sin. There is no extra sin. It doesn't give any new sin. So I'm just lazy to reproduce everything. There is no sin. Yeah, okay. I will just make this propeller turn around, I guess. Propeller. Vehicle. Can I make it like propeller? Public. Game object. Propeller. I will just program. Program. Drop game object. Propeller. Prop. Rotate transform. Rotate. Is it? It's already suggested pretty healthy. Although it's not vector 3 lah. Is front. Gone. It's set tonight. This one is set right, okay. So it's front. Rotation speed 60. Math tab. Is there anything that I can do? Random Team Unity. Huh? What? Why is it not loading? Okay lah. Unity engine random. get behavior of random range changes depending on whether you pass it into integers or floats. Random dot range in min in max. Zero, 1, 2, 3. 0 to 4. 4 is never written. I see. Floats. Decimal number between 0 and 10.0. Both boundaries are inclusive, so 10 also included. If it's integer, if it's 10, 10 is not included. I see. Oh yeah. Random. Random value. Random on unit speed. Rotation. Completely random 3D rotation. Yeah. Okay lah. Let me just do this without the random. See? What's wrong? Vector 3. Run! What a word. Why am I thinking about run? Yeah. I must always remember that it's forward, not run. Thing is rotating. Look at it. It's rotating. Although I don't know why this propeller is added. Why did it get added? How did it get added? Vehicle as planes. Small plane. 2. Simple. Adalah, where everything finished the propeller does not spin. Hence, one even more challenges. Easy to expect difficulty. Bonus feature tutorial. What does it do? Making a making an AI for another vehicle, I guess. And making other car as obstacle. Never mind. I don't want to do that. I will just focus on finishing. Getting like that. I can just duplicate the things and add auto movement. Nice. I will just finish the tutorial and go to the next tutorial. How do you read this tutorial? Challenge ya. Oke lah. I'll check design document. Project design document. Have you been having fun with the
Welcome
course of
to your very first lab session, where you will begin working on your own personal projects.
personal
Unlike the
projects?
prototypes, where we are working on the same type of project together, in these labs, you'll be working on your own project, which will be completely different from mine. You have the great power of coming up with a unique concept for your project.
And
But as
responsibility.
you know, with great power comes great responsibility. You are responsible for making sure you actually finish it. You need to take the time to think through your idea and plan out how you'll get it done. So
Understand
by
what
the
the
end of this
personal
lesson,
project
you will
is.
have completed a design document
You can
for your
totally
project,
skip this.
including an outline of the concept
Personal
and
project
timeline for
videos.
completing it. Here's the tricky thing about coming up with a concept for your project. On one hand, you want it to be unique and amazing and like nothing the world has ever seen. On the other hand, you want it to be complete and functional and playable. You want all of these things, but unfortunately, they're kind of at odds. Now, don't get me wrong. It is possible to create a unique, amazing project like nothing the world has ever seen that is also complete, functional, and playable, but it would just take a lot of time. And I don't mean hours or days, I mean years. And maybe not just years of your life, years of other people's lives. To make some of the console games you might have played before,
You
it
can apply
literally
your
take
feature game
hundreds
here.
of people, thousands of
Skim
hours.
this because it didn't have
Which
any
means we're
other
talking about
again.
hundreds of thousands of human
Now we're
hours
starting this
to
course.
make some of these products. So given that, the trick here is figuring out how much time you have to dedicate to this project, then striking a balance between uniqueness and completeness to get the best possible outcome. Here are 2 tips for how you can do that. First, in this course, as you create different prototypes, you'll learn how to program a ton of awesome different features. So why not build on those features that you'll already know how to program instead of having to figure out everything from scratch?
Understand now what a
The second
primary
thing we do
course.
to make sure we actually complete what we
If
set
you
out to do
design doc
is not try to make a full-featured, production-ready, highly
Project
polished
concept.
project. Instead, our goal will be to make a minimum viable product,
project
or
timeline.
MVP. A minimum viable product is a version of your project
MCP
that
sketch.
has enough features and looks good enough to satisfy early users, allowing you to get feedback for future development. So
Now, we've outlined our ideas through our project concept. We've given ourselves a timeline of what we're trying to accomplish. Now,
Health came out better.
we're going to put our ideas down on paper through a
Scheduling
sketch.
ya.
Now, the sketch will help us really
Something.
visualize.
I don't want schedule. What games are you planning to make? Something like something like this that I've already made. Wait. What is it? I forgot again. Yeah, this one. You see on the screen. I've already made this and I've already made it in the Game Maker Studio. But I'm going to Unity because I want to make it with Live 2D Duo, also Live 2D. Please welcome. I don't know what this is in the team structure. Who is one? Put Unity with Unity window contains a list of all game objects currently in your scene. I can change through all the force Visual Studio is not a part of Unity. You could use a different code editor to edit your scene sharp strips if you wanted to. True, but I don't know how to change. But best describes the difference between the below images. Is it really true? You told me about the JetBrains Rider. It's already spoiled the question. Didn't I? Yes, you did. Was my real voice Grandma? Maybe Grandpa, Grandma. I don't know. I'm the one. The difference between the below images, where the car is in the second image, yes, further along the road, where the car is in the second image is further along the road. The cars. The second car's set location value is higher than the first car's. Oh yeah. Set. In what order do you put the words when you are declaring a new variable? This right? Okay. Data type. Float. Variable name speed. Variable value, yeah. Access modifier. Is it really right? Yes. Following variables will be visible in the inspector. Inspector visible not speed public flood speed one is speed there possible value set but the moving but variable below possible value you doubt it? Yeah, later. This is my test, not your test. Moving input, moving transit value. Get axis horizontal. Move input. Difficult question. You can solve it. Really? Possible value. Possible value set 1 or 0. What is true about the following two lengths of code? They will both move an object the same distance. They will both move an object in the same direction. Stand by. Bye bye. See you tomorrow. January, welcome, Milo. They will both move an object along the same axis. Rotate an object, but along different axes. Yeah. Object the same distance. This 0, 0, 1. This 1, 0, 0. Same distance but not same direction. Check the following lines of code is using standard unity naming conventions. Line A, B, C, D. Standard unity naming conventions. You doubt it? Yes, you doubt it. This question is hard. The P line, P and C line are the same. Why is the P and C are the same? And B and C are all the same. I don't see any difference. That means B and C are wrong. Yeah. Oh, maybe. D. I don't know. select only with. Wait, maybe. But maybe B and C are actually the correct one. But I can only select only one. Despite their fault. I mean, they're the same. Huh? Oh no. Going to be wrong choices. Are you sure? I think, yeah, choose what? From the B and C. Or not. The first letter. The first letter. The action. This move. The M is smile. Oh here. This. This smile. Okay. D. It's D okay na. I just look at the other questions. How many zero do I have? 7 out of the 8. The last one was unsure a little. Its comment would best describe the code below. Moving by measures. Rotate. And count 3 and up. Up is 1. I rotate around the y-axis. Based on left-right arrow keys. Again. Question 10. Which of the following is not a possible way to navigate tricky space in the scene view? Right-click, move mouse to look around the scene. 1 key to get into the first-person view. Or the 3 key to get into third-person view. F2 frame swing that object. The LT, then left click and drag to orbit around friend object. This one is not. I never see this. Okay, submit. Correct answers needed to passage from 10, yeah. Okay, submit. Congratulations, unit complete. You got 9 of 10 correct. Correct. Which one is wrong? The first question was the one that's incorrect. So, yeah. Miho welcome. Tumamao. Tumamamao. Again. In your current scene view, I thought. It should have been Inspector. As persona happening is going down. I mean for me. I need to do things. Other things than gaming. For sometimes. Okay lah. So I've passed this task. The list of game objectives must be the hierarchy. You is the codest of the MC. Laro kami yo. Next up in 3. Basic gameplay. Introduction. Player positioning, foot flight. Random animal stampede. Collision decisions. Play threats. New project with primitives. Sound and effects. Gameplay mechanics. User interface. Top-down game with the objective of throwing food to hungry animals who are stampeding towards you before they can run past you. In objective to this, you will become much more familiar with some of the most important gaming and unique concepts, including if-then statement, random value generations, arrays, collision, detection, prefabs, instantiation. In completing this unit, you will learn how to program a basic game with the ability to launch projectiles, aiming for later to keep the game alive. And it's already night. I will continue tomorrow, starting from the daytime, I guess. Yeah. So tomorrow, I will get to this second tutorial, and then other units of tutorials, I guess. For tomorrow, starting from the daytime instead of the night, like this stream. This stream started in the night. I'm in the evening, so it's a little bit later. But tomorrow I'll start earlier and finish all of this, I guess. Hopefully. No. The unit has some points. No. The other units are not single. They are they have multiple lessons in the list. Oh, okay lah. You can? Well, if I somewhat speedrun and skip what I already know, already have experience, I can be faster, I guess. Hopefully. Yeah. Okay na. See you tomorrow. See you. Have a good day, have a good night. See you next time. Be not long. Long peanut. Me hứa. Stay fast. Then Mary. Mariko này tông băng. Cô chi. Saikoro. Chị perfect. Oh yeah. Corona. And everyone else in the stream. Thank you more. See you next time. See you tomorrow. In early time. Okay. See you.